So what we're doing in this unit is we're really going to focus on drawing graphs. That's it. Okay? But we cannot use a graphing calculator. So one skill that you really have to be good at next year is if you're given any equation, you draw the graph for. So you want to gather as much evidence as you possibly can. So what we're going to do is every day we're going to learn one more thing to be able to draw the picture, right? Draw the asymptotes, the maxes, the mins, the concave up, the concave down, the y-intercepts, the x-intercepts, the horizontal asymptotes. Okay? All of those things help us draw a graph. And by the time we get to the very last day, there are basically, a question would have about 10 marks to it. Okay? Because in order to be able to draw a graph, you want to be able to find anything you possibly can to be able to do it. Now, we have been working with these things called derivatives, so let's talk about where a derivative can help us. Okay? Now, if you do the first derivative test and you find that when you do that derivative, when it's greater than 0, the slope is positive. So this is going to be helpful when you're drawing a graph. You'll always be going up at these parts, right? And f of x, that means f of x is increasing. If you're going to have a positive slope, the original graph must be increasing. Now, if something has a negative slope, so if the slope is negative, then the function f of x is decreasing. The original graph is decreasing. Now, those are good things to know, but more important, we want to know when they're not increasing and not decreasing as well, and that is at the critical values. So critical values are when slopes change. Okay? Now, so when f of x equals 0, you can see that the slopes went from either positive to negative or negative to positive. Now, that's not always true. You can have a horizontal tangent at something like this, right, where there would be a horizontal tangent here. And that didn't really change from a positive to a negative, but it's still considered a critical value because the slope there would be 0. Okay? Now, there is another time that critical values are helpful for us, and that is when f of x, we would say, equals this. Oops, not equals, it equals this. And this is does not exist. So where a derivative will not exist is at an asymptote and when there's a cusp or a corner, because you can't find the slope at this point or this point. So it would not have a derivative there. Okay, so wherever we say the letter CV or critical values, we're looking for when slope equals 0 or does not exist. The first derivative test. Okay, now let C be a critical value, then the function is continuous at x equals C. So if f changes from negative to positive, that would be what we're going to call a local minimum. Okay, I've also heard them called relative minimums. So if you're going from a negative See how these are negative slopes, and then you start getting into a positive slope? It's got to be a minimum. Now that can still occur. See, these are positive, and then they go to negative. So even though here you can say, well, I thought that it doesn't exist there. It doesn't, but it's still a critical value, and if it's going from negative to positive, that C would be where the slope is a critical value. Or, sorry, where it's a critical value there. Here it would be a slope of 0. Here it would be undefined. Okay? So when f, the derivative changes from positive to negative, in these cases here, so it's positive, positive, then it goes to 0, negative. Okay, so then it is a local max at C. So again, here positive, then goes to negative. Okay, so just one more thing to add though. If f of x does not change, does not change signs at C, f of x has no max or min at C. So a very good example would be something like this, where this would be the critical value, but it's going from positive on the left side of the critical value and positive on the right side. So that would not be a max or a min. So don't always assume that if you find a critical value, it's the top or the bottom. Okay, it could be a middle of a graph. Okay, so let's just start from an equation and see how this works. So if f of x is negative 2x squared plus 12x, use 2 points to verify that f of x is increasing when x is less than 3 and decreasing when it's greater than 3. Now, 3 wasn't just a coincidental number taken out, because it would be a critical value. Now, critical values happen when we take the derivative. So let's take the derivative. F prime of x is, okay, we still remember how to do this? What would be the derivative of this? Plus 12. Okay, and then if I was to keep doing this, I would take out a negative 4, and that would be x minus 3. So a critical value is when this equals 0. So a CV would be 3. Now, I'm a very visual person, so I'm always going to put stuff on a number line. So I always draw my number line like this, and then I put 3 there. 3 is a critical value. That's where the slope of this graph is 0. So it could be a max or a min, or it could be just a point within that slope is 0. So it says, is it increasing when x is less than 3? Now, this part of the graph is when x is less than 3, right? So pick a number, like anything in there, and test it. So I'm going to pick 2. Now, if you plug in 2 here, so I use this. Now first, you have your negative 4. So you have negative, and then when you put 2 in here, 2 minus 3, positive or negative? Negative. So you have a negative times a negative. That is positive. So is it increasing when x is less than 3? Yes. Okay? So it's doing this. The graph is doing this. Okay, and then pick something on the other side, because it says, is it decreasing when x is greater than 3? Well, I'll pick 4. So we've got our negative, and then 4 minus 3 is positive. So that is a negative. Okay, so you can see that it is decreasing when x is greater than 3. Okay, so this is the routine that you're always going to go through. Take the derivative, factor it, find out the critical values, do a number line, find out when it's increasing and when it's decreasing. So this, I would say that there is a max or a min at 3. There would be a max at x equals 3. And if to find the exact coordinate, you would have to put it back into here. You have to put it back into the original to get the y value. But this one didn't ask for it. So if I needed to actually find the point where it is a maximum, always go back to the original. One thing that students mistake is they'll put it into the derivative. If you put it into the derivative, you should get 0, right? Because that's what it was, a critical value. Okay, so find the intervals of increase and decrease for this function, okay? So derivatives, once you know how to do derivatives, it really makes your life easier to do these. Even in grade 11, you have to do completing the square and that kind of stuff to find the vertex and find if it's a max or min. This, it's faster to do using derivatives. Okay, so let's do, what's the derivative of this? F of x equals 6x squared x plus 60. Okay, so let's factor it. Oh, yeah, can you guys change this to, I want to make this minus here, or else it doesn't factor nice. It's just an ugly, ugly question. So let's make this minus 60. So minus 60 here. Yeah, it's not going to be a nice question. So let's just change that right in the... Okay, so, yeah, we don't have to do quadratic right now. So let's factor it, because we want to find out when this thing equals 0. So take out a 6 first. Always remember that's x squared minus 3x minus 10. We're looking for two things that add to give me negative 3, multiply it to negative 10. You'll get 6, you'll get x minus 5, x plus 2. So what are the critical values? So CVs equal 5 and negative 2. Okay, so I did the work on the right. Let's do the graph on the left. So I draw my graph. I'm going to write down my critical values on the graph. I've got negative 2 and 5. So this is where I'm going to test where it's positive and where it's negative, where it's increasing, where it's decreasing. Where it's positive slopes, it'll be increasing in the graph. Negative slopes, it'll be decreasing on the graph. So I always kind of pick the value and I just write it down on my graph. So what's less than negative 2? Right? So I go like this. I just kind of put it there for myself. And then I plug it into, so the 6 is positive, right? So we don't have to put a positive sign out front. But negative 3 minus 5 would be, so you don't have to write negative 8, just put negative. And then negative 3 plus 2 would be negative. No. Okay, sorry here, what happened? I did it. I go, oh, I'm looking at the wrong question. Okay, again, I'm like, what? I have positive on mine, but I'm looking at the wrong question. Okay, so negative, that should be a negative again. So I write my positive above. So you kind of want to get in the habit of doing it the same way every time. Put your number, put your and then the number or the big sign on top. So it's positive there. Okay, a number between -2 and 5. Again, be good to yourself. Okay, probably the nicest one is 0, right? But whatever you pick, I'm going to pick 0. So 0 minus 5 is negative. 0 plus 2 is positive. So then I will have a negative here. One thing, because later we're going to be doing second derivatives, let's get in the habit of labeling our number line. This is the first derivative number line. And next, let's use 6. 6 minus 5, that's positive. 6 plus 2 is positive. Positive, positive is a positive. Okay? So what I'll do is I'll actually say, okay, it is positive here, it is negative there, and it is positive here. Maybe because I'm a visual person, that helps me really identify maxes and mins quite easily. Okay, now let's use the notation though. So f of x, therefore, f of x is increasing Okay, what's the interval that it's increasing? Negative infinity, comma, -2. Now, are we using round brackets, square brackets? Round, because if we include -2, it's not increasing there, it's 0. Okay? And then, since there's 2 of them, we're going to use union, and then 5, comma, infinity. Okay, and decreasing -2, comma, 5. Okay, example 3 says, state the domain over which the function is increasing. Okay, well, we know by doing the first derivative. Let's see if you guys still remember how to do this. Okay, how do you find the derivative of this? So 6 comes out front, x squared minus 4 to the 5 times 2x. Okay, so this equals 12x times x squared minus 4 to the 5. So what would make this equal 0? What are my CVs? The first one would be 0 and then plus or minus 2. Okay, so let's go to the number line. We've got -2 on there, we've got 0 on there, we've got 2 on there. Okay, so if I'm going to start, I always go left to right, so anything less than -2, let's go -3. So 12 times -3 would be a negative. And then I've got -3 squared is 9. 9 minus 4 is positive. So I will have a negative right here. Let's use -1. So 12 times -1 is negative. Then I've got -1 squared is 1. 1 minus 4 is negative to the 5th. It's negative. Okay. Then let's try 1. So 12 times 1 is positive. 1 squared minus 4 to the 5th is negative. So this will give me a negative here. Okay, for greater than 2, let's go 3. 12 times 3 is positive. 3 squared minus 4 is positive. Positive times a positive is positive. So it would look like this, right? Down here, then we're going up here, then we're going down, and then we're going up. So it asked, when is this graph increasing? Therefore, f of x is increasing, or increases from negative 2, comma 0, union 2, comma infinity. Okay, so we've done a couple, done 3. The first step is find f prime of x and set to equal 0 to find CVs. Then place CVs on a number line. 3 is state the interval solution. Okay, so it's really about finding when the slope does not exist or equals 0, and then what's going on in between there. That's what's going on either rising or falling on the graph. Okay, now this example here is just a good one, because if you don't see this example, you're just thinking, oh yeah, well, hey, all critical values are going to be a max or a min. I've already kind of drawn this one a couple times for you, but this is the equation, and this is what it would look like. So f prime of x would equal 3x squared. So if I was to, my CV would equal 0, which you can see on the graph. Now if I put a negative 1 in here, I would get a positive value. If I put in 1, 3 times 1, so that's still positive. Okay, so there are no turning points. But 0 is still a critical value. So not all critical values are max and mins. Okay, so we haven't even started talking about maxes and mins. Let's do that now. We'll do a couple questions. So find the local max and min values of x to the 4th minus x cubed. Okay, so let's do the nice easy derivative. F of x equals 4x cubed minus 3x squared. Okay, 0 equals, so what can we factor? I can take an x squared out, leave me with 4x minus 3. So what are my CVs? 0 and 3 over 4. Okay, this is f prime of x. So I'm going to put 0, I'm going to put 3/4. So let's go left to right. I'm going to use -1 here. So -1 squared is positive. 4 times -1 is -4 minus 3 is negative. So this is a negative value right here. Between 0 and 3/4, that's 0.75. So let's pick a half, or 0.5. 1/2 squared would be positive. 4 times a half is 2. 2 minus 3 is negative. So that's negative. 3/4. Then let's go bigger. Let's do 1. 1 squared is positive. 4 times 1 minus 3 is positive. So here we have a positive. So this is going down. That's down. And then we have positive. So now when it wants us to find the local max or local min, is there a local max? No. Is there a local min? Okay. Where is that local min? 3/4, but that's not enough information, right? We need a point. At what point is it a min? We have to take 3/4. So we can say that the local min is at f of 3/4. So that means I'm going to have to find my y value, I've got to go 3/4 to the 4th minus 3/4 cubed, and you will get -27 over 256. Okay. Okay, let's do a bit more of a challenging one here. Find the local max and min values of f of x equals x times the square root of 1 minus x squared. Okay, well the first thing, since we know we're going to be finding the derivative of this, let's get this so it's in exponential notation, 1 minus x squared to the 1/2. We will be using the yeah, but you'll still have a negative x value. Like you'll still yeah, because you don't have to find a common denominator anyway. Yeah, it might. Well, yeah. I'd want to try that one out because usually you shouldn't really factor things in if it's squared, cubed, or whatever. Okay, let's do product rule on this. So it'd be x times the derivative of the second would be 1/2 1 minus x squared to the -1/2 times, I'm going to do chain rule on that, right? So what's inside? What would be the derivative? -2x, good. Plus the derivative of the first, which is 1. No, you don't have to put it in there, but it helps me remember that I actually took the derivative of that. So this is the product rule. First times the derivative of the second plus derivative of the first times the second. Okay. So let's just tidy things up before we do any factoring here, because I've got this x, a half, and -2x. So that's -x squared times 1 minus x squared to the -1/2 plus 1 minus x squared to the 1/2. Okay, now we've got to get this so everything is multiplying to each other. This plus sign, it's much harder to find your critical values, so we're going to take out a common factor. Both of them have a 1 minus x squared to the negative half in them. So f prime of x, or I can even say 0 equals at this point, because that's what 0 equals. I'm going to take out a 1 minus x squared to the negative half out of both. That would leave me with negative x squared plus 1 minus x squared. You can kind of still leave this in brackets if you want, because 1/2 minus a half is 1. Okay? And then you can see that we can get, so 0 equals 1 minus x squared to the negative half times negative 2x squared plus 1. And really, I could put 1 minus 2x squared, so I could keep that, so I don't have over 1 minus x squared to the half. Or you could put the square root sign there. Doesn't matter. Okay. Critical values. Is 0 bad? 0 would be okay. So the 0 might be a little bit misleading here. We also, like when, okay, so if you're not good at this stuff, like figuring out, then you just say, well, when does, if the top equals 0, that's a critical value, right? Because that's when it equals 0. That's in division, the top number decides. So when 1 minus 2x squared equals 0, that would be a critical value. So when 2x squared equals 1, or no, yeah, because if I take the negative off both, then divide by 2, x squared equals a half, when x equals plus or minus 1 over root 2. So this is when f prime of x equals 0. How about when f prime of x equals undefined or does not exist? That's when the bottom of this fraction equals 0. So it would be when root 1 minus x squared equals 0. So if we square both sides, we'll get 1 minus x squared equals 0. X squared equals 1 when x equals plus or minus 1. Okay, so we're still trying to find maxes and mins here. So let's go to our, okay, so we've got, now what's 1 over root 2? You kind of want to know the decimal. It is a critical value because it makes it undefined. Okay, so what is plus or minus 1 over root 2? Just to get a decimal. 0.7, right? So we got negative 1. We got negative 1 over root 2, and that's 0.7, right? Just to give me that, because I have to pick numbers in between. Okay, then I've got 1 over root 2. This would be 0.7, right? And then 1. Now, this graph, when we do these, we're always going to do something before we start, and that's find the domain. The reason why you want to find the domain is because sometimes it saves you time when you get to this step. Because if you look here, do you see how this has to be positive? That means that these numbers greater than 1 and less than -1 aren't even in the domain. So I really wouldn't have to test them. But if you did test these, you would find out that you can't use them anyway, right? So we could say that our domain is between -1 and 1, right? So you don't have to go and test these, but if you did, you'd find out that it doesn't work. Like you can't get an answer because you're going to be taking square root of a negative. Okay, so let's test like you'd have to test like -0.8, right? So if you put -0.8 into 1 minus 2x squared, okay, you might want to try that. What do you get when you put 1 minus 2 times -8, -0.8 squared? What do you get, positive or negative? Okay, you do get a negative over. Now if you do -0.8 squared here, but what do you know that this has to be in here? It's got to be a positive or else you can't take the square root of it. But once you, if you put in -0.8 in here, you will get a positive. So therefore this is a negative here. Well, I should label this as f prime of x graph. Okay, now what is something between these two values? 0. Might as well pick a nice easy one. And then 1 minus 0 would be positive. The bottom will be positive. So you get your positive there. Okay, and then maybe you want to test 0.8. Okay, which would give you, again, a negative. Putting -0.8 and 0.8 gives you the same value because you're squaring it. Over the positive, you do get a negative here. So you get something going down, then up here, and down here. Okay, so let's do local min. Where do I have a local min? At f of -1 over root 2. So what would be the y value of that? You'd go -1 over root 2 times 1 minus 1 over root 2 squared, and that's square rooted. Okay, and just to speed things up because it's a short day, you'll get the answer, -1/2. So you got a local min at -1 over root 2, -1/2. And you'd have a local max at f1 over root 2. So if you put in 1 over root 2 times 1 minus 1 over root 2 squared, you get 1/2. Okay, now when you're doing these, maybe even in your homework and stuff, you might want to just verify it by graphing it in your calculator, but just to show you what this one looks like. So if this was, okay, it actually goes something like this. Okay, that's what the graph looks like. And you can see that this min here, this local min was at -1 over root 2 comma -1/2, and this max was 1 over root 2 comma 1/2. Again, you'd see that this is where the slopes were 0, right? That makes sense. And according to this, because this is -1 over root 2, it was decreasing, then increasing, okay, and then decreasing. Decreasing, increasing, decreasing. So you really want to start to see, how does this relate to this, okay? Well, this is where it starts and finishes. This is where we're at a min. Yep. This is where we're at a max. Yeah. We're decreasing on this side of it. Yeah. We're increasing between these two. We are increasing and we're decreasing. So later we'll be trying to find x-intercepts. That'll help us give us these. Okay. We'll be maybe looking for horizontal asymptotes. We'll be looking for vertical asymptotes. We'll be looking for concave up, concave down, inflection points, all of those things. So we're starting kind of easy on these. Do you guys have the assignment on there? Okay. So it's page 170, 1, 2 ACE, 3, 4 ACEFG, and 5. Page 182, 1, 2, A, B, D, F.